Hello and welcome to another video. In this one we're going to be starting our new unit on linear relations and functions. We'll get into a little bit later what exactly a relation and what a function is, but for now a relation, the basic idea is that it relates one thing to another thing. So maybe like your time to your speed, or your position to your speed, or something like that. So in the first part here it says interpreting graphs. So it says match each graph with a situation from the list. So we got some situations here, and then we're going to pick which graph it goes with here on the right. So let's look at the first one. A, it says the temperature of a cup of hot chocolate over time. So I know that a cup of hot chocolate, as time goes on, the temperature is going to have to start to come down. Okay, and it's going to come down, and then eventually it's going to hit room temperature, and it's just going to kind of flatline and then stay at that temperature. So the one graph that kind of looks like that shape that I'm drawing is graph C. So that is graph C, and then on graph C I'm just going to put that that is time as we go this way. Time is moving on, and the vertical axis, which is this one right here, we're going to put temperature there. So I can see that as time is moving on, the temperature is coming down and then it levels out. Okay, next one, part B, it says a car accelerating to a constant speed. So if a car is accelerating, that means its speed is going to have to increase first, and then it's going to reach a constant speed, so meaning it's going to level out. So we're going to increase our speed, and then we're going to level out. So the one that has kind of that shape is graph B. And then on graph B, again, I'm going to put this is my time. Time you always put on the horizontal axis. That's that one right there. And then on the vertical axis, I'm going to put V, and V just stands for speed. Okay, the next one, the distance a person walks during a hike. So imagine if you were walking to a park and back, the distance that you're traveling, it's going to keep growing, right? You're going to walk there, let's say that's 50 meters, and then you're going to walk back, that's going to be another 50 meters, so it's going to go up again. So this one, the distance you're walking, it should just keep increasing. So the one where it just keeps increasing, we only have two graphs left, is graph D. This one just keeps going up, keeps increasing. Again, put T on the horizontal axis, and then we're going to put D on the vertical axis, and the D represents distance. Okay, and then the last one, the height of a soccer ball kicked across a field. So imagine kicking a ball, it's going to go up, it's going to reach a max height, and then the ball is going to have to start coming down. So it's going to go kind of up and then down. So the one that kind of has that shape, and again, as time is moving forward, is graph A. And then on the vertical axis, I'm going to put H, and H stands for the height of the ball. Now with this one, don't get caught up in thinking that this just looks like the shape of a soccer ball going up and down. Okay, when you kick a ball up and down, it might have this shape, but the only reason that it has this shape on our graph is because as time goes forward, the height is increasing, going up, reaches a max, and then as time continues, it starts to come down. Okay, so it happens to look like the shape of what the ball might look in the air, but that's just kind of coincidence. Okay, we're on to this next part here. It says graphs. So a graph is an effective way to show the relationship between two quantities. So whenever you want to relate two things, like a relation, a graph is a good way to show that. So you could have, for instance, a constant rate of change. So that means it's going to be a straight line. It's constant, it's not changing. You could have a rate of change that is not constant, so for something like that, it needs to have some type of curve on your graph. Or you could have no rate of change, which means that as time is moving along, that thing is staying at the same measurement. So it's staying at this and it's continuing to go on. So we could put like 5 here, maybe that's 5 meters. This is saying that we're staying at 5 meters. We're not going up to 6 meters, we're not going down to 4 meters, it just stays at 5 meters. Okay, so that is no rate of change. And then moving to this last little bit, it says a straight line represents a constant rate of change, and the steepness of the line indicates the rate at which one quantity is changing in relation to the other. So really what this is saying is how quickly a quantity changes. So I'm just going to zoom in and we'll look at each one of these. So I can see with these two here, it is increasing, it's going up, and one of them is moving a lot faster upwards, it's increasing quicker, and that one is this one. So this one is moving faster, and the other one is moving slower. Okay, so that was an increase, or we could have a decrease where they're going down, and we can see that blue line is slower, it's less steep, and the red line is faster, it's falling a lot quicker. Okay, so steepness tells you how quickly something is changing in relation to another. So for an example of something like this, you could have maybe you started at the 10-meter mark and then your distance started to come down, okay? And then as it's coming down, if it's steeper, that means you are coming back a lot quicker to maybe your starting position, whereas this one, it's kind of slowly coming down, so you're not returning down to 0, say your start, as fast. It's just a little bit slower because it's not as steep. Okay, moving on to our next page, we're going to look at an example. So it says the graph below shows the distance that a wakeboarder is from the starting point. Describe what the boarder is doing. Okay, so on this graph, we're starting here, and then we can see on our vertical axis, this is our distance from the start, and our horizontal axis is the time. Always put time on the horizontal axis. So as we are moving away from the start, going away, time is moving forward, and there's different steepness levels on here. Okay, so we're going to have to write out a situation kind of for each one. So we're going to have from A to B, so A to B, B to C, and so on all the way through. So from A to B, I can see that it was kind of less steep, and then all of a sudden it changed and it got steeper. So I got farther, my distance increased quicker, which means I sped up and I started to get farther away quicker. So I began, sped up, and then I reached point B. Okay, so let's write something like that. We could say moving away from our starting point, and then the change in distance starts to slow, so we're going kind of slow, and then it increases and stays constant because this is straight. So let's write that. Okay, so we got from A to B. Now from B to C, I can see that this is flat. Now we said on the previous page when it's flat, that means you do not have a change in your rate. So our distance should not be changing. So from B to C, we're staying at the same point. So either we're stopped or we're just not moving. So let's write that. So our distance is not changing, we're stopped or on some other path. And that other path, I'm going to describe to you what that could be. Imagine that this was our starting point. Okay, I could walk away from that and my distance from it would be increasing. Let's say I got to here. Now if I don't move from this point, my distance isn't going to change. But what if I walked, say, in a circle over to this point? Okay, as long as I walked in a perfect circle, walked over to here, this distance should be the same as what this was. Okay, so the surfboarder could be doing kind of like a circle from his starting point, or else he's just not moving, he's just staying at one spot. Okay, so he's either staying or he's moving around. Okay, next we're on from C to D, so I can see from there his distance started going up, so we went farther away. So we can write that. He's moving away at a very steep rate, so it's at a quicker rate. So let's write that. So moving away at a quicker rate. Then for part D to E, now he's coming back down. So he's returning to his starting position. And he's doing that at about the same rate as this. Same steepness, just coming down. So he is returning back to his starting position. So let's write something like that for D to E. Now we're from E to F, and in here this is a flat spot again. So just like this flat spot, we can write something similar to this. The distance is not changing. Okay, so we're stopped or we're on some other path, like that circular path that I described up here. And then the last one we got from F to G. So here it's not as steep as these, so we're not moving as quickly back to our starting position coming down. But we are coming all the way back down to where our distance, right, if it comes down, it's at 0. So we're returning back to the start. Our distance is at 0. So F to G, we can write that he is returning to his starting point at a constant rate because it was straight. So let's write that. So we're done that one now. Those are all of the different points on the graph where he's going from one to the other. We got one more example we're going to look at. So in this one, and I've kind of already underlined some pieces of information, those are going to be quite useful. So it says, Josephine leaves her home and walks to the store. After buying a drink, she slowly jogs to her friend's house. Josephine visits with her friend for a while and then runs directly home. Using the distances shown, draw a distance time graph that shows Josephine's distance from her house. And here's the distances that we've been given. Explain each section of your graph. So first thing what we're going to do is just make a simple graph going from a distance of, could be at 0 meters, and it's going to have to go all the way up to 1 plus 3. It's going to have to go up to at least 4. So let's draw that. So here is going to be my graph. Again, it's got to go from 0 all the way up to 4, and then time's just going to keep going on. It didn't give us anything with time, so we don't have to put any values on there. Again, always put time on your horizontal axis, and then the other thing that we were talking about was distance, so distance has to go on the vertical axis. Okay, so let's start plotting our points. So it says Josephine leaves her home and walks to the store. So we're going to start, I'm just going to put a dot here. We're going to start at A and we're going to walk to the store. So that means our distance from our home is increasing. So I'm going to draw a line. It's not going to be too steep, something like that. And then I'm going to get to and arrive at point B. So that's when I arrive at the store. Okay, now it says after buying a drink, so that means I had to be there at the store for a while, so that means my distance from the store is not changing, so my distance has to flatline because I'm not going farther away and I'm not coming closer to home. So we got kind of a flat line. We'll get to a point, we'll call it C. Okay, and then we'll go to the next thing. Then it said we slowly jog to her friend's house. So in the beginning I was walking, so that shouldn't be very steep. Now I'm jogging. This should be a little bit steeper. So we want to be a little bit steeper than this line right here. So I'm going to draw something a little bit steeper. And we have to go all the way to this 4-kilometer mark here because it said we were going to her friend's house. And we had 1 plus 3, that's 4 kilometers total. I forgot to mention when we did the first one, when we went to the store, that was 1 kilometer, 1 kilometer, so this had to just go up 1. Okay, so that point at which she arrives at her friend's house, we're going to call that point D. Okay, and then it said she visits with her friend for a while, so that means again we're staying there, our position, our distance isn't changing, so we're going to have to draw a flat line. Then we can put another point, call that E. So we visited for a while, and then it says she runs directly home. So now we are running. First we walked, then we jogged, now we're running. So this should be really, really steep. Okay, much steeper than the other ones. So I'm gonna draw my line, and it said we went all the way home. So it's gonna go all the way down to the bottom, and it's gonna have to be steeper than our other lines. Okay, and then we arrive here, and I'm gonna call that F. Okay, so there's our graph. You could have something that looked a little bit different, but it should look quite similar to what I just drew. Maybe the steepness of these might be slightly different, but this should be less steep, more steep, and then the most steep. And these two have to be flat. They could have been longer, but they have to be flat. Okay, so the last part of this question, it said explain each section of your graph. And we kind of already did that as we were going through, but we'll do it again here. So here I got these different sections, A to B, B to C, and so on. So the first one, A to B, that's when we walked from our place to the store. So let's write that. We did it slowly. So walks to the store slowly, so it's not steep. Then from B to C, we were at the store, so that meant that our position wasn't changing, so our distance doesn't change. So shopping at the store, distance doesn't change. Then for this C to D section, that is where we jogged to our friend's house, so it had to be a little bit steeper. So it was a slow jog to our friends, and jogging, therefore it has to be steeper. Again, this was walking, this is jogging, so this has to be steeper of a hill. So now we were on for D to E, that's where we were visiting with our friends, so our position isn't going to change. So visiting with a friend, distance doesn't change. And then the last part here, when we went from E to F, that's when we were running. So it was really steep, and we ran all the way home, so it came all the way down to the bottom. So let's write that. So runs home, and we were running, so it was really steep. Okay, hopefully that diagram that we drew and the positions from A to B and B to C and so on made sense. If not, you can just kind of flip back and rewatch the part. So now lastly here, I'm just going to write our textbook questions.